Hey guys, it's Fen. In this video I'm going to continue creating our new network library, and I'm going to start with creating a few layers. And I will start with the input layer because that's the easiest one to create, and I'll show you how how we can use this layer class that we have created in the last video. So I'm going to make a new class, input layer. This one extends the layer, and let's start with the constructor. And like we had two constructors. The first one is being used if we know the output size when we're creating the layer. The second one might be used when we do not know the output size yet. But we know the output size obviously because the output size of the input layer is equal to the input size of our network, and this is like what we are starting with. And this is like we always know how big our network, or how big our input size and our output size of our network is. So I'm going to use the first constructor. The second thing that we need is we need to implement a few methods. But the great thing is, in the input layer there's no calculations. Like it cannot calculate the output by taking some input or whatever. There's the onBuild function is like, in here we would usually create some weights, arrays, and so on. Like the input layer does not have weights. We don't need to calculate the output dimensions because we're using this constructor. We don't have to calculate the signal errors of the previous layer because there is no previous layer, and there are also no weights to update. So this is all really remain empty. But what we need is, it's kind of calculate method. Like we need to the output of this layer is equal to the input of the network. So we need to set the input to the network, or the output of this layer. I'm going to make a new method for that, and this will look something like this. So public void set input. Actually, it's setting the output, but it's the input of the network. So I'm going to stick with set input, and I'm going to check if this dot matching dimensions of in is true. Then I'm going to set this dot output values is equal to in. And that's already it for the input layer. I'm checking here if the size of this array matches the output size of the input layer class. Then I need the output layer, and this is also pretty easy. But yeah, it's going to extend the layer, but there are some things happening in here. For example, the backpropagation and so on. So I'm going to implement all these methods first. And the thing is, I'm going to start with the constructor. I think we do not know the output size. Like you need to imagine each layer is being created without knowing what the previous layer is. But the output size of this layer is equal to the output size of the previous layer. But we do not know that when creating the output layer with the constructor. So we have to choose the empty constructor and need to calculate the output dimensions in here. But the output dimension is just the input dimensions, or it's just the input dimensions. So this dot output height is equal to this dot input height. This dot output width is equal to this dot output width, and this dot output height, output depth, there you go, is equal to this dot output. Oh, and it's this dot input. Is there? No. Yeah, like input depth like this, and this is the out input width, like this. So we have calculated the if you remember, this method is being called when we are connecting this layer to the previous layer, and the first thing we're doing in here, like in the connect to previous layer, is setting the input height to the output height of the previous layer. So the output height will be equal to the output height of the previous layer when we are calling this. We have no weights, so we don't need update weights. We need to calculate the previous signal errors. But again, this is pretty easy because let's assume that we have already calculated the signal errors. I'm going to do that next, but let's assume that we have calculated the error signals at our output layer. The error signals of the previous layer is just the same, and we assumed, or we made sure that the size of the previous layer is equal to the size of the output layer. So this dot previous layer, this dot get previous layer dot set output error values is equal to this dot get output error values, or just this dot error output error values, like this. The calculation is pretty straightforward. It's just the output of the output layer is equal to the output of the previous layer, but we must not forget the derivative of the previous layer as well. So this dot output values is equal to this dot previous layer dot output values, and this dot output derivative values is equal to this dot get previous layer dot output derivative values, like this. Just don't forget this line, because if you do this, your network will not be able to train or learn anything. That's like I stumbled across this problem when making this video. Like I was looking for what I made wrong because I missed out. I missed this line, and yeah, just don't forget this, please. The onBuild function, there's nothing we need to do in the onBuild function. But what we need to do is we need to actually calculate these signal errors. And if you remember in the last video, or in the last tutorial, we used the mean squared error to calculate the output error values of our output layer. And what we need for that is we need like some error functions. And I'm going to make a new package for that, because we can have different error functions that we can just plug in however we want. And you can even create your own error functions. I've already shown you the link, I think, with all the different error functions. So I'm going to make a new package, call it functions. In here, I'm going to make a new package called error functions. And in here, I'm going to make a new Java class called error function. There's a synonym for error function. It's the loss function. It's just the same. There's absolutely no difference. So in here we need to this one is abstract, because each error function or loss function will implement this error function, and we need two different methods in here. The first one is there to calculate the overall error of our output. That's like the mean squared error, for example, for the mean squared. And the second one is going to be the output error values of each neon. So for the overall error, I'm going to return a double. I'm going to call it overall error. And what we need is we need the output layer that we're currently there we have the output and everything we need. Output layer, and why doesn't this work? Oh, I think I need to pack all my layers into a package called layer. This would make sense, I think. Can I import it now? Yeah, I can import it now. Okay. And I need the expected output, because this is not stored in the output layer. So the expected output. And like this needs to be implemented by the cost function or loss function or error function. It's all the same. And the second one is going to be the applying it on an output layer to calculate the signal errors. So public abstract void. I'm just going to call it apply. I hope you all know what is meant by that. Output layer, and also we need the expected output, because like the loss, obviously, for the loss we need like the output, for example, and the expected output in most cases. And I'm going to create the mean squared error, so MSE, and this extends the error function. And I need to implement some methods, of course. The overall error, oh, I misspelled this one. Let me quickly correct this. So refactor rename overall error, like this. So in here, the overall error of our mean squared error is like we need to the function was to sum up over all differences squared and then dividing by the amount of output neons times 2. So it might sound complicated, but this is I've shown you everything in the previous tutorial, so I'm actually going to copy this, so it would look something like this. This is the expected output, expected like this. So I'm iterating through all three output dimensions. I'm having a running a value v, and I'm increasing it by the difference squared. So the output layer dot get output at ing times the expected output at ing. It's j, sorry, j, times that same thing again. So we are pretty much squaring this up. I have another variable c, it's called c. Actually, this is not like, it's just counting how many output units we have. I could also remove c and ask for the length of these layers, or of these arrays, but I just use c to, and I'm increasing c, and the overall error for the mean squared error is v divided by 2 times c. Like we could stick with v divided by c, but like sometimes it's v divided by c, sometimes it's v divided by 2c. That really doesn't matter. And the to apply, the first thing I'm going to do is I'm going to extract some values that we are going to need. So for example, we need the output of our output layer. It's just like, it makes things easier to read. Then we need the output derivative for, we need this for our calculations, is output layer dot get output derivative values, and we need the error signals to, like the output and the output derivative is used for calculating stuff. The error signal array is the actual array of our output layer that we're going to write to. Error signals is equal to output layer dot get output error values, like this. Then again, we need to iterate through all three dimensions, like this, but we don't need the c variable anymore, and we don't need this. If you remember, the error signal at our neuron ij is equal to the output derivative, so the output, it's derivative, I think, ij times the difference between the expected output and our actual output. So output at ij minus the expected output at ij, and that's it. So this we are writing through this error signals array, and we are not copying or cloning any array in here. So we are actually just immediately writing to the error signals array of our output layer. So yeah, that's exactly what we want. In here, I'm going to have an error function. So private error function, and I'm going to need some getters and some setters for that. And I'm going to use something that might look maybe kind of stupid, but it's very nice to work with. It might look, I don't know how to say it, but for every setter function that I'm going to work with in our layers, I'm going to return the layer itself. So output, I'm going to return the output layer, because at the end we can do some very smart, some very clever things with this, and it's just like very easy to work with at the end. What else do we need? Like, it could happen that we are not setting the error function, then in the on build, I mean, we don't have wakes, but we have the error functions, and this must never be null. So this dot error function, or if this dot error function is not equal to null, or is actually equal to null, then this dot error function is equal to a new mean squared error. So the mean squared error will just be the default error function. Let me quickly check if I've missed something. I think I haven't. Yeah, actually, I actually need to use the error function, because that's one that I haven't done that yet. So public void calculate output error signs. So I want to calculate the error signs of my output layer. And after we would do this, we could like calculate the signal errors of the previous layer, like applying the backpropagation algorithm. So calculate output error signs is just the start of our backpropagation. What do we need for that? We need the expected output, like expected. I'm just going to use EX. That's like faster to type. And then the only thing that we need is we need to call error function dot apply on. I think it needs the output layer, which is this, and it needs the expected output. And we want to get the overall error as well. So public double overall error of an expected output, and this is equal to error function dot overall error of this and the expected output. I need to return this like this, and that's already it for the output layer. That should work like this, I think. In the next video, I'm going to create the fully connected layer, and after that, I'm going to create the network class, and then we should be done with our new library. And then I'm going to start with implementing some new stuff that you haven't seen yet, which will probably take some more time. And I hope to see you in the next video.